let's go over how to read a thermal model for an aluminum window. All right, so I have a bunch of documents for us to review, but before getting into it, I want to establish what the point of this exercise is. A, we want to spit out our overall window performance values to make sure that we're in line with our performance criteria. But B, by running this 2D isometric thermal assessment, we're able to better understand how the window performs as a whole, and to ensure that any of these interior components don't fall below the dew point so that we don't risk condensation on the interior surface. So first, we want to establish our 5 boundary conditions. A, the indoor-outdoor temperature conditions. So here you can see we round up and down to 0 degrees Fahrenheit on the outside, 70 on the inside. Number 2, what is our relative humidity? So with a 40% relative humidity, the dew point is at 44 degrees Fahrenheit. So it's critical to ensure that none of these interior components fall below 44 degrees. So when running this thermal 2D assessment, you could see this black squiggly line is called an isotherm. And at this point in time, all points along this line are at 37 degrees. So you want to make sure that we never reach the point where this black squiggly line reaches the interior components here. And so what's contributing to that is all of our thermal break components within our mineral wool insulation, our foam fill, our polyamide thermal breaks within the frame and the sash, and then our optimal edge of glass components here. So further boundary conditions, we want to pick our glass makeup. We have a double glazed IGU with our coating on the number 2 surface. And past just our center of glass coating U factor, we want to ensure that we have optimal edge of glass performance, and that will enable us using a warm edge spacer as well as an argon fill within the cavity. So again, you want to look at the IGU performance as a whole, not just center of glass. And lastly, we want to look at the window size and operability type. So here we have an NFRC size, an operable awning window in the size of 24 inches by 59 inches. And with all those boundary conditions, we spit out our total window results, including a U factor, solar heat gain, condensation resistance, and visual transmission. So again, the objective here is to get our total window performance criteria to plug into our energy model, but further, we want to understand the performance of the window as a whole to ensure that we don't risk condensation on the interior part of the frame components in a real life